Now, the next presentation is to Mehrnoush Ebadi from Italy, who will present exploring the antibacterial effects of Urtica dioica leaf oil extract against Escherichia coli and Staphylococcus aureus.
To present my research titled The Antibacterial Effects of Urtica dioica leaf oil extract against two common bacteria called the Escherichia coli and Staphylococcus aureus. We have two main goals in this study. First, evaluating the antibacterial effects of nettle leaf oil on two bacterial strains, and second, investigating how altitude influences the bioactive compounds and antibacterial properties of the plant. A quick overview of Urtica. Urtica, or nettle, is a well-known medical plant with antioxidant, anti-inflammatory, and antibacterial properties. It contains active compounds like phenolics and flavonoids, which contribute to the plant's healing effects. Let me explain how we collected the samples. We collected nettle leaves from Bustar in Iran, a region with diverse altitudes, sampling from 3 different elevations: 2,000 meters, which is the highest elevation, 1,000 meters, and finally 100 meters, which is the lowest elevation. This range allowed us to compare impact of the elevation on the chemical properties and the antibacterial activity of the plant. Take a look at our target bacteria. We focused on two bacteria, Escherichia coli and Staphylococcus aureus, both common human pathogens in clinical infections. E. coli causes urinary tract and gastrointestinal infections, and Staphylococcus aureus can lead to skin and more serious infections such as bacteremia and pneumonia. Now, to study the bioactive properties of the plant, we first of all extracted essential oil using hydrodistillation, a method involving steam. And then we measured the total phenolics, flavonoids components, antioxidant strength using the DPPH method, which gives us a IC50 value, and finally antibacterial effects using MIC test against two bacterial strains. Move to key findings, starting with phenolic content. We found that the samples from higher elevations showed more phenolics, as you can see in the figure. For example, the sample from 3,000 meters had over twice the phenolics compared to the one from 100 meters. But in case of flavonoid content was slightly different. Based on the figure, the highest flavonoid was found not at the top elevation, but at 1,000 meters mid-elevation. This nonlinear pattern tells us something, that different types of compounds can be in their highest value in different elevations, which can be due to environmental stresses. Then looking at the antioxidant activity. The lowest IC50, which indicates stronger antioxidant power, was found in the 3,000 meter sample. And so, again, high altitude plants showed better antioxidant performance. Now, what about antibacterial results? As you can see in the table, with the lowest MIC for both bacteria in high elevations, it shows stronger bacterial inhibition. Also, there is a significant correlation between antioxidant activity and antibacterial activity, which the samples with stronger antioxidant properties had better antibacterial effects. Finally, as a conclusion, our results show that elevation affects the chemical properties of Urtica dioica. Neutral from higher elevations had more bioactive compounds, and it leads to better antioxidant and antibacterial performance. These results highlight the potential application of the Urtica dioica extracts in antimicrobial and antioxidant treatments. Thank you for listening.